Hey everyone, today is day 2 of my 30-day SQL query challenge. Yesterday's video was amazing. There was amazing response. In fact, it was the most viewed video on my channel ever in the first 24 hours. So thank you so much for that. Now let's continue with our video number 2, that is our query number 2. And trust me, it's going to be more interesting than yesterday's one. Let's start. Okay, so what you see here is basically a real interview problem that was shared to me by one of my subscribers in my email. Now, it's a pretty lengthy problem statement, but it's very important to read through it and understand it properly before we can solve it. Okay, so first let's spend some time to properly read through the problem statement and understand it. Okay, so a ski resort company is planning to construct a new ski slope using a pre-existing network of mountain huts and trails between them. A new slope has to begin at one of the mountain huts, have a middle station at another hut connected with the first one by a direct trail, and end the third mountain hut, which is also connected by a direct trail to the second hut. The altitude of the three huts chosen for constructing the ski slope has to be strictly decreasing. Okay, now this is a very important point. What basically they are saying is there is a ski resort company. It is trying to build a new slope, okay, or basically a new trail which connects to three different mountain huts. Okay, so there will be a starting mountain hut. Okay, it will connect to a middle mountain hut. Okay, and then from the middle mountain hut it connects to the ending mountain hut. Okay, and there needs to be direct connection between these two mountain huts. So the trail that we are going to build needs to be directly connected from the start mountain hut to the middle mountain hut, and then from middle mountain hut to the ending mountain hut there should be a direct trail. Okay, and they are saying that the mountain huts, the altitude of them needs to be decreasing. Okay, so the starting mountain hut should be at the top highest altitude, then the middle mountain hut, and then finally the end mountain hut. Okay, now you are given two tables, mountain huts and trails, with the following criteria. Now this is basically the data set, okay, that they have given two tables with some data. I have already created that tables. Okay, I'll show it in some time. Okay, now here you can read some more information. So basically they're saying each entry in the table trails, okay, represents a direct connection between huts, okay, with IDs hut 1 and hut 2. Okay, and note that all the trails are bidirectional. So if I show you the data, you can see that these are the two tables. So there is mountain huts. Okay, there are 5 different mountain huts that are available. Their ID, their name, and their altitude is mentioned here. Okay, then we have the trails table. This basically tells the trails that are currently already built. Okay, so hut 1 and hut 2. So hut 1 is basically one mountain hut. This is the second mountain hut. So you could say that this is the starting point and this is the ending point currently. Okay, so the first the trail that has been built is between the mountain hut 1 and the mountain hut 3. Which is mountain hut 1 and 3? That you will find it in this table. Okay, 1 and 3. Okay, so that is what is provided here, and they are saying all these trails are bidirectional. That means if you have a trail, let's say between 1 and 3, that means you can also consider like the trail between 3 and 1 is also existing. Okay, so they are all bidirectional. You can move from 1.1 hut to another, or you can come back as well in that same trail. Okay, so that is why they call it like bidirectional. Now what we need to do is create a query that finds all the triplets: start point, middle point, end point, representing the mountain huts that may be used for the construction of the ski slope. Output returned by the query can be ordered in any way. Okay, now I'll explain you what that means. So first of all, you see here, this is our table. As I showed you, 5 different mountain huts. This is the mountain huts table. Then we have the trails table. There are these trails that are already built. Okay, so there is a trail between the hut 1 and 3. There is another trail between the hut 3 and 2, etc. But this is just like 2 huts, right? These trails are built between 2 huts. What we need to do as part of this problem statement is we need to give the ski company that is trying to build the slope the options of how they can build the 3-way trail. Okay, so between 3 different huts. So you need, so this is basically the output they're expecting. Okay, and here the output is basically providing the name of the mountain hut. So they are saying you can have one trail between Dakonut, and then the middle point can be the Gajantut, and then the ending point can be Tupur. Okay, similarly you can build 4 different trails using the data that is given in these 2 tables. Okay, we need to write a query to come up with this output. Now, there are few important things that we need to consider. I'll explain this in detail in some time. But before that, let's look at some assumptions that they have given. So they are saying there is no trail going from a hut back to itself. So always a trail starts from one hut and it will go to another hut. It will never come back to itself. Okay, that's one thing. Then for every 2 huts, there is at most one direct trail connecting them. So they are saying between the 2 huts, maximum there can be only one trail. You cannot have 2 huts and there are 2 different trails for them. No, there will always be maximum one trail between the 2 huts. And then they are saying each hut from table trails occurs in the mountain huts. That means every hut that you see in this trails table is basically present in the mountain huts. You cannot have a trail here which is not present in the mountain huts. Okay, that's not going to happen. Okay, so this is basically the data set that we have been given. Okay, now before even I can solve it, I just want to tell you what we need to do. So we have this trail which connects from between 2 different huts. We need to come up with an output where we can tell them that if you're building a trail between 3 different huts, what are the possible routes that you can take. Okay, here we are saying from Dakonut to Gajantut to Tupur. Now Dakonut is basically, I think, yeah, you can see here it is 1. Okay, so from 1 you can go to 3. Okay, so 3 is, I think, Gajantut. Okay, that this basically is already given in the input. Okay, then from Gajantut to Tupur, so from 3, that is 3 is Gajantut, so 5 is Tupur. Okay, this is possible. So this connection you can build using this data. Okay, but you might ask, why not from 1 to 3 and then 3 to 2? Okay, 3 to 2 is basically from Gajantut to Natisa. You can see that from Gajantut to Natisa we do not have any record here. The reason is the altitude. They mentioned in one place in the beginning here, this point, the altitude of the 3 huts chosen for constructing the ski slope has to be strictly decreasing. That means the starting hut's altitude needs to be the highest, then middle hut should be the second highest, and end hut should basically be the least, should be present at the least altitude. Okay, so this 3 2 does not satisfy that condition, and that is why it's not present in the output. Okay, now I hope you understand the problem statement. Now, as I told you yesterday, what you need to do as part of this 30-day query SQL query challenge is you will find a data set and the problem statement, everything in my blog as well as in my Discord server. You'll find the link in the video description. Go to the blog or the Discord, download the data set, try to solve it using any database. I will be using PostgreSQL and pgadmin tool. You can use any database of your choice. Okay, solve it and then share your solution in the Discord server. Okay, there is a new channel that I have created in the Discord server. You will know by the name. You can just paste your solution there and then discuss with the community, share your ideas, help each other, etc. Okay, now I'm going to solve it and let's start. So in order to solve this, I already have created the tables as I showed you. So I have the mountain huts table and I have the trails table. Okay, now what is the very first thing that I need to do in order to solve this, right? So first of all, I know that I need to build the the trail which connects between the 3 mountain huts, right? The data that is given is only connecting between 2 different mountain huts, right? In the trail table, right? But you see that here everything is mentioned in the form of IDs. It is not very clear for me to understand which mountain are they talking about or which mountain hut are they talking about. Secondly, I also need to know the altitude of each mountain because I need to know if I know that from 1 to 3 we can build the trail because it's already present in the output. But from 3 to 2 it's not possible because we saw that the altitude restriction that was there, it does not satisfy, right? So along with these IDs, we also need to know what is the name of the hut and also the altitude of the hut so that then we can use that to form our final logic. Okay, so the very first thing that we need to do is somehow we need to join these 2 tables such that we can take the details of each of this hut. Okay, so that is exactly what I'm going to do. Okay, so what I'll do is I will just let's say maybe I'll just put it here. Okay, I'll just join the mountain huts table and I'm just going to call it like H1 and I'll join it with the trails table. Okay, so I'll just join it with the trails. So join with the trails table, and I'm going to call it like T1. Okay. And then how do I join it? So I know in the trails table I have hut1 and hut2. So I will say T1 dot hut1. Okay. Equal to, I know that in H1 I have the ID field. So if you see here, I have this ID field in the mountain huts table, right? Now, if I join this, and let's say I'm just going to fetch T1 dot star, comma H1 dot star. Okay, if I run this, now you can see that this is my hut1. Okay, this is basically all the other details of that hut1. Okay, because you see that I joined hut1 with the ID from the mountain huts table. So you see here this hut1 and this ID is basically in sync, and the name of this hut1 is Daconut, and then its altitude is 1900, etc. Okay, so I have got the name and the altitude for my hut1. Now, how do I get those details for hut2? Now, you might think that you could just use another join here and join it with hut2. That will not work. Okay, if you want, you can try it. You will see your results. You're going to lose some records. Okay, that's not the right way. Ideally, what is the best way to do here is you need to use this result set and join this result set with the mountain huts based on this hut2 column. Okay, so to extract the details for hut2. Okay, so what I'll do is I'm just going to move this into a CTE. Okay, I could use a simple subquery as well, but just to keep the query more neat, I'll use a CTE. So I'm just going to call it like CTE hut1 as, and I'll move this to the right. I'll enter this, and here I'll just tell select star from CT underscore hut1, and I'll just call it like, let's say T2. Okay, that is for my trails because this is my trails table. Okay, in fact, instead of calling it like hut1, I'm just going to call it like trail. Okay, trail1. Okay, just to make it more meaningful. Okay, or trails1. Okay, so I'll call it trails1. Okay, and then I will query the data from that trails one. Okay, and I'll give an alias T2. I'll join it with the mountain huts table. So I'll just copy this. I'll put it here. I'll call it H2. Okay, how do I join it? H2.id is equal to T2 dot. Now I need the details for this hut2 field, right? So I will say here hut2. Okay, and let's keep it as star, and I'll execute it. Now you can see that. So hut1 ID, name, and altitude. This is all the details of my hut1, that is mountain hut1. Okay, so its ID, its name, and its altitude. And what you see here, the hut2. Okay, so if I just remove this hut2 ID, name, and altitude, this is basically all the details of hut2. Okay, so this is how I have joined. Okay, because the mountain huts ID was scattered across two different columns, I had to do this kind of a join so that I could get the details of both the huts. Okay, without losing any records. Okay, so this was basically my first step. But if you see carefully, there are a lot of unnecessary columns. I don't need this ID, and I don't need so much, right? I can make it more neat. So what I'll do here is I'll just tell, okay, maybe I will just move that here. Okay, in fact, I'm also going to rename this hut1 hut2, because ideally, what is hut1 hut2? Hut1 is the starting hut, okay, start hut, and hut2 is the end hut, right? The trail starts from hut1 and the trail ends at hut2, right? But hut1 hut2 can be pretty confusing, so I'm going to give more meaningful name to this column. So I'll do that here. Okay, so if I just execute this upper city, I have this hut1. So what I'll do is T1 dot hut1. I'm going to name it like start hut. Okay, and then I will say, so I have got this. I don't need this ID, but I need the name. So I'll say h1 dot name as start hut name. Okay, and then maybe I'll move down, and here I will say h1 dot altitude, right? Altitude as hut. Okay, maybe I'll just copy this. Start hut ka altitude. Okay, so I have got the hut ID, I have got the hut name, that is a start hut name, and I have got the altitude of my starting hut. Okay, the next thing that I need here is basically the hut2, right? So I will say, let's say T1 dot hut2. I'll rename it like hut2. Okay, I'll say this is my end hut, right? And not hut2, just end hut. Okay, so my hut1 is my starting hut, and my hut2 is basically my end hut. Okay, so now if I run this, you see now this is the data I had after renaming of the columns. I just renamed the columns and ordered it better. Now it makes more sense. So my starting hut ID, starting hut name, starting hut altitude is mentioned on the left hand side, and the trail ends in this hut. That end hut ID is mentioned here. Okay. In order to get the name and altitude of that, I'm using this query here. Okay. And from here I can just tell t2 dot star. Okay. And then I'll say h2 dot name as I will call it like end hut name. Okay. And then I'll say h2 dot altitude as end hut altitude. Okay. So from this table, when I joined it with hut2, I took its name and made it like end hut name and the end hut altitude. Okay. So if I run this, I'm getting an error because I changed the name here. So it is not hut2 anymore in the CT, it is end hut, right? Now if I run it, now you can see that the first three fields are the details about the starting hut. The last three fields are the details about my ending hut. So my trail that currently exists starts from here and it ends here. Okay. So this is the details that I have got. Now I think it is more meaningful because I can see the ID, I can see the name, and I can see the altitude, right? Why I needed this was because I needed to do one important, I wanted to implement one important functionality here. That is, my whole intention is I want to start from a hut, go to the end hut, and I should see from this end hut, that is somewhere here, do I have any other hut connecting to it, right? So 1, 3, and then this 3 and 5. So I could basically build a connection like 1, 3, and 3, 5. So 1, 3, 5 would be a possible trail that I could build, a three-way trail, right? A three-hut trail. Now that is what I want to build, right? But when I'm building this connection, important thing that I need to consider is the altitude. My starting altitude has to be the highest, then the middle altitude has to be lower than that, and the end altitude or the end hut has to have the lowest altitude, right? So basically, if I look at each record here, so let's start with the first record. The starting hut is at an altitude of 1900. The end hut here is at an altitude of 1600. So I think this is satisfied. So altitude is decreasing. So the upper hut is at the top, lower hut or the end hut is at the below that, right? If I go to my second record here, you can see that my starting hut is Gajantut. It is at 1600 altitude. Okay. Whereas its ending hut Natisa is at 2100. This does not satisfy our condition that was given in the problem statement. They said that the start and the end, basically it has to be decreasing, right? So it cannot, this record I cannot consider as it is. Okay. But they also mentioned one more point. Okay. And that one more point was the trails are bidirectional. I think they mentioned it somewhere. I think here. So the trails are bidirectional, right? So this is mentioned here. So what this means is if I can interchange the position here. So I cannot build a trail from Gajantut to Natisa because their altitude are not decreasing. But if I could reverse them, so if I could build a trail from Natisa to Gajantut, then I think that will work, right? So what I could do next is I have this result set. Wherever I see that any of the record does not satisfy my decreasing altitude condition, I could replace their mountain huts, right? So this end hut, I could make it like start hut, and this start hut, I could make it like my end hut. So basically the first thing I will need to do here is to come up with a flag so that I can identify which are the records where I need to change its position from start to end and end to start hut. And I can easily do that by using a case statement. So here I can just say case when, I'll say like my start hut altitude is greater than my end hut altitude. End hut altitude is basically this one. If it is greater, then I say it satisfies my condition, right? So I will give the flag like 1, else I'll give the flag like 0. I'll call it end and I'll name it like, let's say, altitude flag. Okay. And if I just run this, now you can see that I just got this new column here, and wherever it is 1, that means this start and end hut is it's fine. Okay. Its altitude are in sync with our requirement. Okay. But wherever the flag is 0, that is, I think these two record, you can see that the flag is 0. That means its start altitude is lower than the end altitude. We cannot have that, right? So for these two record, we need to bring the end hut as our starting hut, and we need to move the start hut into our end hut. Okay, and that is what we will do in the next step. Okay, so what I'll do is I'll just move this to the another CTE, okay, just to keep it neat, and I'm just going to call it like CTE trails 2 as, and I'll just move this again little right, and I'll have this here. I'll close this, I'll add a comma here, and I'll have my select. So I'll say select star from CT underscore trails 2. If I run this, I still have the same data. What I want to do here is, based on this flag, okay, I need to come up with what is my start hut and my end hut. Okay, and after that, I will not be bothered about altitude. Only to make sure which is my correct start and end hut, I wanted the altitude. Okay, so what I'll do here is I'll add a case statement saying that case when uh, altitude flag is 1. Okay, if my altitude flag is 1, that is in this particular record, then my start hut can stay as it is. Okay, then my start hut is start hut, this one. Okay, and basically I could end it and I could call it like start hut. Okay, so I'm trying to find my start hut and my end hut. Okay, so if the altitude flag is 1, my start hut can stay as it is. So for the first record, this condition will get satisfied and the start hut would be the Daconut. Okay, that is fine. But when it comes to the second record, you could see that this condition will fail. Okay, altitude flag is 0. In that case, I cannot consider my start hut to be Gajantut, but I want Natisa to be considered as my starting hut. So here I'll add an else saying that my end hut should be treated like the start hut. Okay, I hope you understand. Okay, and the same thing, so this condition case statement I added to find the start hut, I'll add the same case to find the start hut name. Okay, so here I'll say just to get the name. Okay, and I'll say again the name here and start hut name. Okay, so if I just run this, now you can see that I have got my start hut. So I have kind of like, I have Daconut, Natisa, Gajantut, Tupur and Daconut here. Okay, but I also need the end hut, right? So for that, what I'll do is I'll again copy this whole case statement. I'll put this here. And if the altitude flag is 1, I'm trying to find the end hut. So I will say end hut. Okay. If the flag is 0, then I want to do the reverse. So wherever it is end hut, I want to take the start hut. Okay. And this I'm basically calling like end hut. Okay, and I'll do the same to find the name of the hut. So here I'll say name, again I will call it like name, and again here I will call it like name. Okay, and now if I run this, now I am basically getting the data that I wanted. Okay, so I have, let's see the first record. Okay, and let's compare it with the input that we had. So I have start hut and end hut. So start hut is 1, end hut is 3. If I go to my input, you see that I have 1, 3. Okay, so it is basically as same as my input that was given. The second record is 2, 3, 2 and 3. But here it is kind of, the input was 3 and 2, right? We interchanged it to 2 and 3. Why? I told you the reason, because here the altitude was not decreasing. So I had, using that flag, I reversed this position. So Gajantut was here in the start and Natisa was in the end, but I replaced it using this case statement here. Okay, so this basically is actually the correct position of the huts that I want based on my condition. So that, because Natisa is at a higher altitude and Gajantut is at a lower altitude. Okay, so this kind of makes sense. Same way for the third record, I have 3, 2, 5. So this is 5, 3 and 5. I think that is correct. The fourth record, it is 4, 5 and 4. Okay, previously in the input it was 4 and 5, but because it had this altitude was not decreasing, I replaced its position. And the fifth record is 1, 5, and that is exactly how it was in the input. Okay, so what I basically have currently is I have the correct data in the correct order. When I say order, basically based on their altitude, so that now I could use this result set to finally build the 3-way trail that I actually wanted. Okay, so now if I, even before I proceed, let's try to analyze what I have. So here, what are the trails that I could form using this data set? Okay, so I have there is one trail that I can, one trail that I can start from hut 1, go until 3. Okay, then 3 here goes up to 5. So I could say 1, 3, 5, right? So 1, 3, and then 3 goes to 5. So 1, 3, 5 can be one possible 3-directional trail that I can build, right? Same way. Now, if I go to the second record, I have 2, 3, but again 3 goes to 5. So I could here again have 2, 3, 5, right? Same way, when I go to my third record, I have 3, 5, but 5 goes to 4. So 3, 5 and 4 could be another direction. 3, 4, was it? No, 3, 5 and 4. Okay, this could also be uh, another possible trail that we can build. Finally, okay, not finally, but in the fourth record, I have 5 and 4. So from 5, I can build a trail which goes to the hut 4. But from 4, there is nothing that starts, right? So I cannot build a three-way trail using this record, right? So I can ignore this. If I go to the last record, I have 1, 5, but 5 goes to 4. So I could build another trail saying that 1, 5, 4, right? So, and I think that's all. So these are the 4 three-way trails that I can build using the given data. Okay. So I hope you understand this. And if you try to compare these IDs with the expected output that we have here, it is basically the exact match. Okay. So you can do that check. Now, how do I use this result set? Okay. And come up with an output which looks like this. Okay. Can you think of a solution? Now, one way, what I basically need to do here is for every record, when I'm processing every record, I take its end hut and search for that end hut in the start hut. Okay. So I need to join the same table to itself. And this is where we could use a self join. Okay. So what I'll do now is I'll just move this to the right. Again, I'll build another CT here. Okay. And I'm going to call it like my final result. Okay. CT final as, and I'll put a comma here, and I'll put this whole thing into the parenthesis, and I'll have my final query. So I'll say select, let's say star from CTE underscore final, and this will be C1 because I told you I need to join this table to itself, right? So self join. So I'll join the CT final to itself, and I'll call it like C2 on. Okay. So how do I do the join? So I said from the first table, I take the end hut. So C1 dot end hut. Okay. I want to match it with the start hut from another table. So that is C2 dot start hut. Okay. So I hope this works. So let's see. I'll just move this down and let's see if this actually works. Okay. So if I just run this, you can see that I am getting the data that I want. If you look at the first record, from Dakonut, that is my starting hut, I can build a trail to Gajantut. From Gajantut, you can see here, I can build a trail to Tupur. So from Dakonut to Gajantut, and from Gajantut to Tupur. Same way from Natisa to Gajantut, from Gajantut to Tupur, and same way from Gajantut to Tupur, and from Tupur to Rifat, and finally from Dakonut to Tupur, and from Tupur to Rifat. Okay, so I can build all this, and this is basically how I actually wanted here. Okay, in my final output, but I have some I don't need all of these columns, so I'll just keep the column that I need. Okay, and I'll rename it based on what is expected in the output. Okay, so I'll say C1 dot start hut name as my start point. Okay, start point. Then I'll say C1 dot end hut name as my middle point. And finally, my final end point or end hut would be C2 dot end hut name, and this will be my end point. Okay, so if I run my query now, and I'm getting an error because it should be a dot. Now if I run it, now you can see that I'm getting the final output. So start point, middle point, end point. So this is basically the solution to this particular problem. I am sure many of you guys would have a different solution to this problem. If you have, or if you don't have, share it in Discord. I would be very interested to see what are the different ways we could solve this problem. Okay. Thank you so much for watching. Be active in this challenge and let's learn from each other. So I'll see you again tomorrow with a more interesting problem. See you. Bye.